My name is Gaurav. I'm a data scientist from Grab's mapping team. It's fantastic to see such a large group of developers, machine learning engineers here today. I hope you're having as much as fun as me. Okay. Yeah, so some of you may, in this room, may have seen Grab. You may have used Grab today while arriving at this venue, or may have taken a Grab bike during your holiday to Bali. To give you an idea, 12 years back when we started, our mission was to make taxi rides safer in Malaysia. We were in one country, one city. Today, Grab has become one of the leading super apps in Southeast Asia, with 1 in 20 people using it for food, rides, and payments. That's over 41 million monthly transacting users. We are committed to driving Southeast Asia forward, not just through traditional services like ride-hailing and food delivery, but by literally putting our region on the map. Today, I'm excited to share a snippet of how our very own Grab Maps is truly disrupting the traditional map-making space together with OpenAI. Okay, so for some context, Grab Maps began its journey in 2017, before COVID, and we increasingly found out that the third-party apps were not localized enough for the region. We had several issues in terms of not having granular enough view of the region, or the data was quickly obsolete with significant lag with respect to how quickly the real world evolves. Today, Grab Maps intelligence services not just serves our internal requirements for 8 countries we operate in, but is also an enterprise-grade solution that supports businesses across Southeast Asia and beyond. Our approach to Grab Maps is rooted in community-based mapping centered around precision. We collect street-level imagery using 360-degree cameras, which are in-house, leveraging our vast driver network, and similar to the image that you see in the middle of the screen. From these images, we extract a lot of details like turn restrictions, traffic signs, speed limits, places, road accessibility, and so on, helping us build the map road topology. This level of complexity is key for creating reliable and hyper-detailed maps. Now, switching gears a bit, as you know, GPT-4o text models fine-tuning has been there from early this year. 2 months back, OpenAI released this vision fine-tuning capability to customize vision models with strong image understanding capabilities. We have been one of the early adopters for vision fine-tuning API, and in the next part, I shall show an example of how we leverage this newly introduced feature on a data matching problem for Grab Maps. To briefly introduce the task, given street imagery with traffic sign, we intend to match it to the road the traffic sign is placed on. Given criticality of information like speed limits presents its own unique challenges. For example, you can have geometries that can be very intricate, visual occlusions that can make automated matching very difficult. To address this, we turn to GPT-4o fine-tuning with our in-domain data, allowing us to handle these complexities effectively at scale. All right, to give an overview of the experiments, we started with a small fine-tuning data set combining street-level imagery and map tiles, much like you see on the screen. To add some context, we have 2 consecutive map views at the top of the screen and corresponding street-level imagery, let's call them as frame 1 and frame 2. Each map tile contains the position of the vehicle marked by the red dot that you see at the very intersection of the 2 roads, and the position of a traffic sign that is marked by the small letter U that you can see on the left of that red dot. There's a green bar